Today we are going to describe fundamental theorem of integration and some properties of definite integral. For a continuous function f of x over a closed interval ab, if there exists a differentiable function capital F of x on closed interval ab, such that f of x is equal to derivative of f of x. Here keep in mind that this function is called primitive of these functions. Then the integration from a to b f of x dx is equal to taking integration of both sides of this integration from a to b prime of x dx. This derivative will cancel with the integral, and this is equal to f of x is limit from a to b. When we put limit, upper limit minus lower limit, this is called the fundamental theorem of integrations. Now these things can also be explained by Riemann theory. According to Riemann theory, the integration of from lower limit to a b f of x dx is equal to limit n tends to infinity delta when delta x tends to 0. This summation k start from 1 up to n mk delta x k. Here you know that this is come from partitions. When we take a partitions and take the sum of limit, sum of the areas. Then similarly, integration from a to upper limit f of x dx limit delta x tends to 0 and tends to infinity mk delta x. Here this is denoted by L f of p limit delta x tends to 0 and n tends to infinity, and this summation we denoted in previous lecture by u f and p upper, and this is lower. This is the sum of right endpoints, and this is the sum of left endpoints. When these both sums are equal, then such integral from a to b f of x ds is called Riemann integration. In other words, we say that f of x is Riemann integrable if the upper integral and lower integral are equals. Now we going to describe some properties. Here keep in mind that these properties are very useful in evaluation of definite complicated integrals. Property first, integration from a to b f of x dx is equal to integration from b f of t dt. If the domain of the function x and t is same, and if a function is differentiable at x, then it is also differentiable at t, and we can write the integral as. Similarly, property 2, integration from a to b f of x dx is equal to minus integration from b to a f of x dx. If a body is moving from a to b, this is integration from a to b f of x. But if that body is moving in reverse from b to a, then this is minus integration from b to a f of x dx. These both integral are equal, that is in opposite directions. Property 3, integration from a to b f of x dx. If there is a point between a and b such that integration from a to b, there is a point c, a less than c less than b, we can also integrate integration from a to b as integration from a to c and integration from c to b f of x dx. Similarly, property 4, integration from 0 to b f of x dx is equal to 0 to a. Integration from 0 to a f of a minus x dx. So here in right, this property will be highly useful. Here the x variable is replaced by the difference of upper limit minus x. So here we convert this right hand side to left hand side, putting a minus x is equal to t, differentiation minus dx is equal to dt, dx is equal to minus dt. If lower limit x is equal to 0, then t is equal to a, because putting x is equal to 0, then t is equal to a. If x is equal to a minus a is equal to 0, t is equal to 0. So this integral become s. At 0 t is equal to a, at t is equal to a, x is equal to a, t is equal to 0, f of t minus dt, taking minus out from a to 0 f of t dt. Using property 2, using this property, this minus will be reverse the integral, and this will become again minus plus integration from 0 to f of t dt. Using property p1, this is integration from 0 to a f of x dx. Similarly, this is another property 5, integrations from minus a to a f of x dx. Here keep in mind, if this function is even, then we can write this integral 2 times integration from 0 to a f of x dx if function is even. If the function is odd, then this integral become 0. Here note, if f of x is even function, then we know that f of minus x is equal to f of x. This is called even function. That is cos x x square x absolute example of even function. Even function graph are symmetric about, for example, f of x is equal to x square, then its graph become as. Similarly, if f of x is equal to x absolute, then its graph can be read as and as, which is symmetric about the origin. Similarly, if f of minus x is equal to minus f of x, then such a function is called odd function. For example, sine x is odd function. You know that sine minus x is equal to minus sine x, and x and x cube are even function. Graph of even function is passing through the origin. Property 6, integration from 0 to twice of a f of x dx, which can be written as 2 times integration from 0 to a f of x dx. F of 2a minus 6 is equal to f of x, and this becomes 0. F of 2a minus x is equal to minus f of x. Now another property is 7. F of a minus 6 is equal to f of x. Then integration from 0 to a x f of x dx is equal to 1 over 2a 0 to a f of x dx. So we can prove this property as integration from 0 to a f of x dx, which can be written using the previous property, replacing x by a minus x. A minus x, putting a minus x here, and a minus x f of a minus x dx. So multiplying a f of this f of a minus x is equal to f of x. So integration from 0 to a f of x dx, this is minus, and x, so f of x 0 to a dx. Now taking this integral on left side, 0 to a f of x dx and 0 to a x f of x dx, and this become a 0 to a f of x dx. So adding and simplifying, we get the required result. Now, dear student, we use that properties and solve the problems. First example is from minus 1 to 5 x minus 2 absolute dx. Here you know that if we put x minus 2 is equal to z, then dx is equal to dz. If x absolute is equal to z, then if z greater or equal to 0 and z less than 0, then it become minus z. Using this property, we know that from minus 1 to 2, this function become negative. So minus 1 to 2 minus x minus 2 dx, plus from 2 to 5, this is positive, 2 to 5 x minus 2 dx. Evaluating this integral, this is a simple integral, x square by 2 minus 2x, and this is x square by 2, and this is minus 2x, upper limit and lower limit. Now putting the value of limit in calculation, simplifying, we get required result 9. Thank you.